In this example, we would like to evaluate the definite integral from 0 to pi of the function sine squared. Now, something that's very important to remember is that if we ever want to anti-differentiate sine squared or cosine squared, we need to remember the corresponding half-angle formulas. So for sine squared, it is equal to 1/2 the quantity 1 minus cosine of 2x. If it was cosine squared, let me just remind us of that formula as well. It's identical, except instead of separating with a minus, we separate with a plus. And if you ever want to anti-differentiate cosine squared or sine squared, you need to know these formulas. So let's rewrite in terms of this half-angle formula. We have a 1/2 that pulls out front. And we have the antiderivative from 0 to pi of 1 minus cosine of 2x. And once we've rewritten in terms of this half-angle formula, what remains are two functions, the 1 and the cosine 2x. And both of these functions are extremely reasonable for us to anti-differentiate. Antiderivative of 1 is x, and an antiderivative of cosine 2x is 1/2 sine of 2x. And if you don't immediately see that the antiderivative in this case should be 1/2 sine 2x, you could, to the side, do a substitution, let u be equal to 2x, or we could very easily check this via differentiation, thinking about the chain rule. And we need to evaluate from 0 to pi. So we plug in a pi, so we'll have pi minus 1/2 sine 2 pi. Then we put a minus sign and we plug in 0. And everything here except for the first term is going to vanish. Sine of 2 pi is 0, sine of 0 is 0. So when the 1/2 distributes through, we end up with the quantity pi over 2.